In this lesson on sequence, we are going to introduce to you very basic fundamental concept. We will also look at what have we learned in our earlier grades. So take a look at this very simple example that let's say you deposit some money in your savings account, right? And then you deposit 10,000 to begin with. And let's say this is the timestamp equal 0 in years, right? Because this is where the start of this sequence is. And then you earn some interest on your money. It's a rate of interest 10%. All right. So what happens, assuming that you don't take anything out, this 10,000, it becomes 11,000, right? At the end of year 1, this is the timestamp in years. Then just like that, it goes from 11,000 to 12,100, assuming you still don't take it out from your bank account, and likewise it will go one more year. So at the end of third year, you have $13,310 in your bank account, right? Every year your money gets multiplied by a factor 1.1. Now what exactly you notice here in this set of numbers? What we notice is that the money grows, and it grows in a predictable fashion. That means you have been able to define your relation from first number to the second to the third and to the fourth, right? And that is called a sequence. A sequence is a set of numbers written in a specific order, assuming that we can predict that order from one number to the next number. That's all about a sequence. So let me give you one more example. Now take a look at this pictorial view of representing sequence. So my very first diagram, the one that has 6 dots total, we have organized these 6 dots to look like a triangle, right? There is one dot at the top, then there are 2 dots below the first row, then there are 3 dots below the second row. In every row, the number of dots go up by 1, right? Now, when I look at my second diagram, we have exactly same pattern. We have 1, we have 2, we have 3 dots, and then we have 4 dots. And likewise, when you look at the diagram number C, you will see that, okay, I can still predict the same relation that 1, 2, 3 dots, 4 dots, and 5 dots. So how do you see this is related to the example of sequence? The example we can say is that we can create a triangle by dots, right? But every time you increase a row in this triangle, you have to increase the number of dots by 1, right? Now, I'm going to give you some more examples to give you an idea the different kind of sequences we come across in mathematics. So take a look at these 3 examples we have. Let's analyze our very first set. Let's say this is my set A, okay? In this one, I begin with a number 1. Then as I go from 1 to 3, I see that there is a difference of 2 between these two numbers, right? Then I go from 3 to 5. I still see that the difference is still 2. The next number is 2 higher than the previous number. Then you go from 5 to 7. And then likewise, you go from 7 to 9. That means you can predict your relation between the numbers, and as you keep going up, the numbers will keep increasing by 2 at each single increment. So this is a very simple example of a sequence, right? Now let's analyze the set number B, all right? It also begins with 1, but as I go from 1 to 2, it has a difference of only 1. But as I go from 2 to 4, it goes up by 2. And then I go from 4 to 8, it goes up by more than 2, right? But I see that if I multiply 1 with 2, I get the next number. If I multiply 2 with 2, I get the next number. Likewise, from 4 to 8, I simply have to multiply to get to the next number. Then it keeps going up like that forever, right? So this is another example of a sequence. The difference between A and B is, in the sequence A, I am always adding 2 to the previous number. But in the sequence B, I'm multiplying by 2, right? Let's analyze the set C. It is different compared to the first 2 examples. It still begins with 1. So let me write this in a fractional way. So this is 1 over 1. The second number is 1 by 3. I can write this as 1 over 1 plus 2. The third number is 1 over 5. That can be written as 1 over 1 plus 4. The fourth number is 1 over 1 plus 6, because 6 and 1 will be 7. And likewise, the last number is 1 over 1 plus 8. So what I notice is that the numerator is always 1, but the denominator, it keeps going up by 2 units, right? That's what is the trend you are finding here. So every denominator is 2 units higher than the previous number, right? So it is somewhat similar to the sequence A, but in this case, the sequence C has a denominator, not the numerator, which is going up by 2 units. So what is the purpose for me to demonstrate to you these 3 examples? Each one of those represents a different kind of a sequence, okay? And those are called 3 different sequences that exist in mathematics. The very first one, what we saw, in which the successive number is 2 units higher than the previous number, is called an arithmetic progression, okay? And the second one, in which we saw that the next number can always be obtained by multiplying 2 to the previous number. This kind of sequence is called a geometric progression, all right? And the third one, in which you have a fractional kind of a sequence, but it can be related to arithmetic progression. The only difference being that it is the denominator which is in the arithmetic progression, not the numerator. So such sequences are called the harmonic progression, okay? But in this module, our focus is on arithmetic progression. That is the scope in our grade, and this is what we are going to focus mainly on. So mathematically, we can write that a sequence can be written as a set of numbers such as A1, A2, A3, A4, right? Where the 1, 2, 3, 4, it just represents to you that these are different numbers. So a sequence is a set of numbers written in a specific order such that we can always predict a relation between one number to the next number. Okay, so that is a sequence. Now, what exactly is a series? In sequence, we talk about the numbers individually, but in series, we say that a series is a sum of the terms in a sequence, meaning when we say that there is a series S2, for example, then with reference to the sequence that we have, let's say A1, A2, and so on, series S2 means the sum of the first 2 terms. So it will be written as A1 plus A2. So let's say, keeping the same sequence in our mind, if I say S3, it means that it is equal to the sum of the first 3 terms of that sequence we are talking about. If I write the word S4, it is written as sum of the first 4 terms. All right, just like what you see on the screen. And a general representation of a series is that it can be written as Sn, where n represents the n terms of a sequence, and it is equal to the sum of those specific terms up to the nth number, whatever we have this n stands for, okay? So this is how we define a series versus a sequence. So the fundamental difference between a sequence and a series, always remember, a sequence is a set of numbers written in a specific order. A series is a sum of the terms in a sequence, okay? So with that, we will take a pause here, and in our next few tutorials, we will learn about the terminology as well as more formulas related to the arithmetic progression sequence.